probably no surprise to you that a lot of meteorologists give their pets weather-related names. Stormy and Doppler are two that come to mind immediately for dogs. I always think about this in early August because it's the time of the year often called the dog days of summer. And for the origin of that term, we need to look to the stars and a few thousand years back in time. Now, the brightest star visible from Earth, other than our own sun, is a brilliant blue-white star called Sirius, a name that comes from a Greek word for scorching. The ancient Romans and Egyptians called Sirius the dog star because it's in the constellation Canis Major, Latin for the greater dog. In constellation lore, Canis Major is one of the hunting dogs of Orion the hunter. In fact, a line drawn through the three bright stars in Orion's belt points approximately to Sirius. Now, because Sirius is so prominent, it was easy to track for early civilizations around the Mediterranean. In those days, during April and May, Sirius was low in the southwest sky after sunset. But in midsummer, Sirius rose and set at about the same time as the sun, so it was essentially lost in the daytime glare with the rest of the stars. But the ancients knew the dog star was there, in the sky with the sun during the hottest time of the year. So they figured that heat from Sirius added to the heat from our sun to produce the peak warmth of summer. The ancient Romans called that period of time Caniculares Dies, days of the dogs, and it lasted from about the first week of July to the second week of August. Now, don't get me wrong, Sirius is very luminous. If Sirius suddenly replaced our sun in the sky, daylight on Earth would be about 25 times brighter than it is now. But Sirius is also about 500,000 times farther away than our sun, something the ancients didn't know. So how does the energy we get from Sirius compare to what we get from the sun? Well, as a start, you might estimate 500,000 times less because of the difference in distance. We might write it this way. Then we have to multiply, of course, by 25 to take into account that Sirius is brighter than our sun. But in reality, the amount of energy we get from a star depends on the distance to the star squared. So you have to multiply that 500,000 by itself. Now we'll simplify this estimate, as we like to say here on Weather World. We always do the math for you. And in the end, the energy we get from Sirius is but a very, very, very small fraction, about 1/10,000,000th of the energy we get from our sun. So tiny that it really plays no role in heating the Earth. And that's true not only for Sirius, but for any star other than the sun. So I guess you could say that blaming the dog star for helping to boost summer heat on Earth is, well, barking up the wrong tree. Stay tuned. We'll see if there are any dog days of summer in store in our extended forecast next.